Hello everyone, welcome to our pre-calculus pre-recording video. This is our first video for this semester for the level 200. In this lesson, we will review the concept that is discussed in the level 100. So, which is a review from the linear and quadratic functions. We will actually discuss about the graphs, functions and their graphs, then linear and quadratic functions. So all of them are here in this one lesson. Because it is a review, that's why we have them compiled here. Okay, so let's look. First of all, very important concept. What is a function? We will discuss about a function a lot. So what is a function? A function is something, you can consider the function as a machine. So in a machine, you give some input and machine gives some output. Let's think it as a garments factory. You give some thread or other things, clothes, just big clothes. Then after the production, you get the shirt, pants, etc., etc. Okay, so function is something like that in mathematics. When you give some input, some number in a function, after doing some work there, it gives you some another number output. Let me show you an example here. So fx equal to 5x plus 20. This is a function. Why it is a function? If you put x equal to some value, suppose x equal to you give 5, then 5 into 5 plus 20. Answer is what? Answer is 20 plus 5 into 5 means 25. 20 plus 25 means 45. So you see, in the very normal way, if you look at this, you will see just 5, you are giving input, then this mathematical thing converts this number based on this condition and gives you the output 45. This is a function, kind of like, if you think it's like a machine, it changes your number. Of course, it will change always by keeping this principle in mind, and you will automatically know beforehand. You will always know what number will come out. What number will come out, you will know based on your condition here in a function. Okay, so the function is a kind of machine. It changes your number, and if you give a number, you will always know what number will come out. 45, then if this is the function, then another answer. If this is the function, then another answer. And all of them are function. What is the domain of the function? Domain is this 5 in our example. Range is 45 in our example. Domain is the input, range is the output. So if you give here after 5, if you give another number, all of them will become the domain. And for all of them, you will get some answer. They will be the range. So domain is the x value. That means what are the value you put, that are the domain, and range are the output or the y value. Fx means y, by the way. This fx, we can consider them. This is like implicit and explicit way of writing function. So basically they are just representing the y value. So that's why it is said that output is the y value or the value of fx, if you want to say. Okay, domain is the x value, this value, x value. You see, we have put x equals to 5, domain, and then after the calculation you get the fx equals to what, which is 45. That is the range. So we have some graphs here. What is the domain and range? Of course, the function is given here. Fx equals to, this red color is the red graph, this one is the green color is the green graph, and then this color is something, I'm not sure what is this color called. This color is let's say XYZ color. I do not know the name of this color. This color is mauve. I have seen this color. This is called in some, anyway, somewhat close to purple, is it? Anyway, so this is the color. So what is the domain and range? Domain and range of this one? We can just look at the graph, and this graph will go this way forever and this way forever. So basically, the domain in the both side it will spread. So domain will be all real number. This one range also all real number, because x and y value will keep coming for this one. But for this graph, you will notice that for this graph actually you will not have, the graph is up until here, and there is in the below this point there is no other graph. So although for this graph domain is all real number, in the left and right it will spread forever, but in the downside it has some ceiling, it has some boundary. Not ceiling, actually it has some base. Below this there is no graph. So the range will be from this point somewhere here, 5 point something, to the plus infinity. Okay, so the range is restricted here. In the last graph here, what is the domain and range? You will notice that if x equals to 0, then the function is undefined, because you see graph will not come x equals to 0, but everywhere else you will have the graph. So the domain will be all real number other than 0, and range is also all real number other than 0. As you can see, the graph is in the above the y line, above the x line, and below the x line. In the both side we have the graph. So when the graph is given, you can actually look at the graph, and then you can say what is the domain and range. Just look at the graph, and then we can say it. You will have to see in x direction what is happening, and in the y direction what is happening. From the x direction you will get the domain, from the y direction you will get the range. Is this a function? So we have a nice example here. You have some envelopes, and you can put the envelopes in some post box. So here say these are the setup. Now based on this setup, which one is function, which one is not. If you look at this, then you will notice that you can put this envelope here, no problem. You can put all the envelope goes to some post box. Here also all the envelope goes to some post box, but -1 and -1, both of the envelope goes to one box, no problem. But in this case, you see this -1, this envelope goes to two boxes, which is impossible, because you cannot put one envelope in two box. Then you will have to cut it to two part. So it cannot go. This envelope cannot go to two different box. It has to either go to one or go to two. Okay. So this is, of course, this is not mathematical. This is some conceptual or pictorial representation of function. This one actually is not a function, because here you have for one input you have two output. That's why. For one input you have two output. That's why. Or based on this concept, you can think, okay, one envelope I cannot put in two box. I have to put it either this box or that box. So if this kind of situation comes, we will say this is not a function. Everywhere else this is a function. Okay, this is the example, kind of like what can happen here. How can we get this kind of situation? Now linear function. This is basically the equation of a straight line. Linear functions, all of them are equation of a straight line. We have the standard form, slope-intercept form, and point-slope form. Slope-intercept. This slope is m, y-intercept is b. That's why it is called slope-intercept. Point-slope. Slope is m, a point is x1, y1. That's why it is called point-slope. That means in this form, a point and a slope is necessary. In this form, the slope and y-intercept is necessary, and this form can work with everything. I mean, this is a simplified version. You can just bring everything in the one side and keep the constant in the right side, then you get this. From here also you can go there. All of them is actually interchangeable. That's true. And these things what we said is written here. Okay. Slope of horizontal and vertical line. So slope means change in y divided by change in x. So for a horizontal line, what is the change in y and change in x? You see, let's say if you want to consider from this point to this point, so what is the change in x? Change in x is 1 box, 2 box, 3 box. So change in x is 3. What is the change in y? There is no change in y. We cannot go up or go down because the line is not going up or down. That's why it is 0. That's why the slope of any horizontal line is 0. And similar concept is here. Slope of any vertical line, in this case y direction, x direction, there is no value. That's why it is 0. So anything divided by 0 equals to undefined. So the slope of a vertical line is undefined, slope of a horizontal line is 0. You can find it from the calculation also, you will not have to memorize. This is a modeling you may have remembered. Actually, those who have finished level 100, you may remember all of this in some degree. So this is linear modeling. When you have some scatter diagram means all the points are scattered here and there. So this is called a scatter diagram. So from here you choose two best points so that they represent the trend of the data, and they are somewhere in the we will have to choose them in such a way so that equal number of points up and down. We say that. Then choose two good points. Of course, if it is too complicated, then actually you can do some approximation also, little wild approximation. But the rule is equal number of points up and down. So you choose that 2 points. Then by using that 2 points, you can use the formula that we discussed, like point slope form or slope intercept form, whichever you are good at. You can use them to find out the equation of the line. When you have 2 points, first you have to find out the slope, then use the slope in the slope intercept form, in the point slope form, to find out the equation of line. It's done here. First we find out the slope, then we use it in the point slope form to find out the equation of the line. Once you can find out the equation of line, then you can extrapolate this equation of line to find out what will happen in the future. Like after, suppose this point is not, we do not know this point, we do not know for sure, like what happened here, what happened here, what happened here in this case, and in some other case we can actually go beyond this also. So in this case, equation of line, equation of a straight line, this is the application of equation of a straight line. Now quadratic. The quadratic means like ax square plus bx plus c. This kind of form is called quadratic, where there is x squared. This is important. X squared is important here. Then it becomes quadratic. This is the graph of quadratic. This is called let me say, this is called the line of what is it called? This is the vertex. Let me, it will come to my mind. Just give me a second. This is the vertex, the point where the graph actually stops increasing or stop decreasing. In this case, the graph was decreasing. This is, suppose if you are here, then you go down. See, this line is decreasing, and you come up until here. Up until here the line was decreasing, then it started increasing. You will have to start from the left to right, and then we come to this point. That's why it is called the vertex. This is called the vertex. Oh, this is called the line of symmetry. Okay, now I remember. This is called the line of symmetry. Why it is called the line of symmetry? The reason is, about this line, your left side and right side is same line of symmetry. So let me give you an example. From here, if you go to the right, you get a graph like 1 box, 2 box, 3 box. If you go 3 box, you get your graph. Then from this point, if you go to the left side 3 box, then you will get your graph. Like 1 box, 2 box, 3 box, then you get your graph. So that's why it is called line of symmetry, because from this line, right side and left side is same. That is why it is symmetry line. Okay, this is x-intercept, x-intercept, this is y-intercept. All right, so graphing a parabola using a vertex form. This is the vertex form of a quadratic function. This h comma k is the vertex. This A represents how much wide or how much narrow the graph is, and if there is like plus or minus sign, it will represent, is it open up graph or open down graph. Okay, h comma k is the vertex. We have example in the next slide. Even here also you can see it. Like, okay, if it is 0.5, in this example actually we can discuss it. If it is minus 0.5 x plus 1 whole square plus 3, how can we make a decision where it will go? Yeah. So you see, minus h comma k is the vertex, so they basically minus 1 comma 3 will be the vertex, because this minus 1 comma 3, this is the vertex based on this rule. Okay, so minus 1 is here and 3 is here. That means this center should go there. This should be the vertex. Okay, and this is minus, so the graph should be down opening. And there is a 0.5. 0.5 means the graph will be wider. Yeah, the graph will be like wider, kind of like this. Okay, in other words, if you see some number here outside this all this thing here, as you can see here, if you see this number, this is plus 3, so for this plus 3 the graph will go 3 unit up. And for this one, this number here, if it is x plus 1, then the graph will go in the negative direction 1 unit. If it is minus 1, then the graph will go in the positive direction 1 unit. If this number is positive, graph goes up. If this number is negative, graph will go down. And for this minus, as I said, for this minus, the graph will flip. The graph will have a reflection about the x-axis. So see if it is happening here. So first of all, for this plus 1, the graph goes to the minus 1. Why it happens, if you ask, the reason is, what value of x will neutralize this part? This is, if x equals to minus 1, then it will be minus 1 plus 1 equal to 0, 0 whole square. That is the reason why at minus 1 it goes, because x value needs to be minus 1 to neutralize this term here. Then for the plus 3, graph goes there, and for the minus, the graph is flipped, and for the 0.5, graph becomes wider. Okay, so this is how it happens. Factoring quadratic function to find the x-intercepts. So from if you look at this, x squared minus twice x minus 8, we can factor it like this, and we will get two value here, a and b. They will represent, like if it is x plus a and x plus b, then x equal to minus a and x equals to minus b will be the x-intercepts or roots of this equation. We have example here. Let me show. So here, let's say anyone we can actually discuss from here. All of them are similar kind of concepts. So let's say this one, all of them are similar. So let's say this from this line, x square minus twice x minus 8. So from this um, expression here, we can go to this part, which makes it equation, of course, but they are equal. So x plus 2 and x minus 4 comes by factoring, okay, by middle term factoring. Let me show you that part. X squared minus twice x minus 8, and this factoring we can do it in two ways. Some students does it this way. They break it down, break down this number 8 and find out what combination will make it will give us a minus 2. So 8 we can divide into two parts, like 2 and 4. 2 into 4 equals to 8. Then 4 minus 2 equals to 2. So to get this minus 2, we will have to give a minus with the 4 and plus with the 2. Then we will get a minus 2. And then this plus sign and minus sign, we'll have to make it minus. This is another way to verify. So x square minus 4x, then plus twice x, then minus 8. We will not change anything here, but this minus this equal to this again. Okay, so we have it. Then we take x common. So x minus 4. Then plus we take a 2 common from here. Then x minus 4. So we have x minus 4 here. Then we have x plus 2 here. Now to get our intercept, this has to be equal to 0. Then this equals to 0. This equals to 0. This equals to 0. Let me write it here. You will understand it clearly if I write the whole thing. This was fx equals to, let's say, some function. Fx means y. Y equal to 0. That means we are finding x-intercept. Okay. Here it is written x-intercept. X-intercept means y equal to 0. Y equal to 0. So y equal to 0 means what? Fx equals to 0. Okay. So once you have, in that case we will have to change the symbol this side. So once you have this into this equal to 0, that means from the zero product rule, we can write individually this equal to 0 or this equal to 0. So if we write x minus 4 equal to 0, x minus 4 equal to 0, so x equals to 4 will come. Then x plus 2 equal to 0, then x equals to minus 2 will come from here. What does it mean? It means that our graph will have intercept with the x-axis at 4 and at minus 2. So if I try to draw the graph of this function, so the graph will be somewhere here. Let's say this is minus 2 and this is 4. So the graph will be something like this. Something like this. This is a parabola, right? So that's why I'm just approximating this parabola. This is our minus 2, this point. This is our plus 4, this point. And what is this point? This is the y-intercept, and we can see the y-intercept is minus 8. So this point is actually minus 8. Because if x equals to 0, then what is the value? That is the y-intercept. So you see, this actually helps us even in the drawing of the graph also. Okay. So x-intercept, the roots of this of the quadratic function gives us the x-intercepts. They have multiple applications. Yeah, they have multiple applications. This factoring gives us this x-intercept. Yeah, this is the answer. Now, what if you cannot do the factoring? Then we use the quadratic formula. Yeah. If you use this formula will directly give you the x-intercept without any factoring or anything. You can use this formula everywhere. This is called discriminant, this value. If this value is 0, then there is only one x-intercept. If this value is greater than 0, there is two x-intercept. If this value is less than 0, that means negative number, then you have no x-intercept, because this function in that case becomes undefined. Square root of negative something is undefined. So here a means -3, b means 7. See the color coded, -3, 7 and 12. What are the x-intercept? You will notice that you cannot actually break it down to make +7. You can try, but you will not succeed to get the 7. There are many cases of this kind, and in all those cases, actually this formula helps us. So x equals to this formula we use. Based on this formula, a equal to this -3, b equal to this, and c equals to this, we put it here in this formula, then we get two answers. These two are the x-intercept for this function. And from the decimal number, you can actually tell that you cannot do the middle term factoring actually for this function. So you will need this formula many times. Okay, this is called the quadratic formula, and you can solve all the math by using this quadratic formula when you are trying to find out the x-intercept. Even the math that we have seen in this page also, this math also you can solve by that formula. In that case, a equal to 1, b equal to -2, c equals to -8. You will just have to use it here. Okay, so this formula is very powerful. We call it silver bullet, because this is the bullet that you can shoot and you can have anything. Of course, it has to be quadratic first of all. Yeah, so it's written here also. Maximum value and minimum value. So see this graph, maximum value is somewhere here. Okay, this is the application of quadratic. Vertex of a quadratic function. Quadratic function is its maximum, or in some cases minimum also. Let me give you an example of minimum. Suppose if the graph is like this, then the vertex is the minimum, and all other points is maximum. So vertex can be maximum or minimum. And so vertex x value -b by twice a, we can find out this value by using the -b by twice a from this formula, from this given function. And if we use this value back in the question, then we will get for what value here it becomes the maximum. So let me restate it. If you use the -b by twice a, you will get the x value. That means where it is, which value is here, you will get that value. And then if we use back in the question, then we will get which value here. It gives us the maximum. In this case, revenue and price. So x value will give you the price, and y value will give you the revenue. That's what I'm saying. Okay, in this case. So this is the application of quadratic function, by the way. And how you get the x value? If you ask it once again, -b by twice a, this is the formula for finding the x value. And how you get the y value? The rule is f of -b by twice a. That means whatever the value you get in this calculation, you will have to put that value here, then you will get the y value. So this way actually we can find out maximum or minimum value for the quadratic function by using it. This is different form of quadratic function: standard form, vertex form, intercept form. Just like our linear function, there are different forms here as well, and they have advantage in different cases. Suppose in some cases, if you need intercepts, then this form is better. If you need graphing, then this form is better. And and if you want to find out the x-intercept, y-intercept from the quadratic formula, then this form is we use this form. So all of them has different usefulness. These are in class practice, so during the class time we will try to practice this kind of functions. This one, and this one. You all can give a try to find out the solutions of this by yourself, so that you come in the class prepared. Okay. I think that's all for today's pre-recording. Thank you all. Thank you very much. Have a good day, everyone, and see you all in the class. Bye-bye.